through some practice proofs using the triangle congruence theorems and postulates. Okay, so this first one, you're told that AB is congruent to BC, so I'm going to go ahead and mark my picture, and that's from given. From here, that doesn't tell us anything, so we're going to move on to the next given that says D is the midpoint of AC. From here, if D is the midpoint of AC, then we know that AD is congruent to DC by definition of midpoint. Now, we can see that we have two triangles here, right? We have this triangle to the left, ABD, and then we have the triangle to the right, CBD, okay? Well, if we want to prove those two triangles congruent, we already have two sides congruent to two sides. Well, if we know that three sides of one triangle are congruent to three sides of the other, the triangles are congruent. Well, they share the side BD, so we can go ahead and say that BD is congruent to BD by the reflexive property of congruence. Okay, so essentially if you were looking at this triangle as separate from the other one, then you could draw this down here and we could go ahead and label it. We know this is A, B, D. And go ahead and mark your picture. And then if we drew the other one, B, C, D, again, BD is congruent to itself, BC is congruent to BA, and DC is congruent to DA, so we can see that those triangles are congruent by the side, side, side postulate. Okay, so from here, we knew that when three sides of one triangle were congruent to three sides of the other, the triangles were congruent by the side, side, side postulate. From here, we're going to go ahead and move down to the next proof. This one tells us that M bisects PN and KQ. So we're going to go ahead and write that down. Now that tells us that M is the midpoint of PN and M is the midpoint of KQ by definition of midpoint, or by definition of bisect. So if M is the midpoint of PN by the definition of this term bisects, then we know that PM is congruent to MN by definition of midpoint. From here, we also can see if M bisects KQ, then M is the midpoint of KQ by definition of bisects, and KM is congruent to MQ by definition of midpoint. At this point, our givens don't tell us anything else, so now you have to go and look at the picture. Well, if we look at the picture, I can see that I have vertical angles right here. Well, we know vertical angles are always congruent, so I'm going to go ahead and say angle PMK is congruent to angle NMQ. And notice P and PM is the same length as NM, so I put those in the same spot. And that's because, and the reason is vertical angles are congruent. Well, from here I can see I have a side, then an angle, and then another side, congruent to a side, angle, side. You always take the shortest path. I wouldn't go side, skip all these angles and sides to go side, angle. You take the shortest path. So side, angle, side is congruent to side, angle, side. So I can say triangle PMK is congruent to triangle NMQ by side, angle, side postulate. Now this one tells you that you're given that angle D is congruent to angle C, so I'm going to go ahead and write down my given. I also know that DB is congruent to CB by given. So I'm going to go ahead and mark my picture. Well, again, at this point, our givens don't tell us anything else, so I look at the picture and I can see, oh, I have vertical angles right here. So I'm going to go ahead and say angle ABD is congruent to angle EBC because vertical angles are congruent. Now I'm going to mark my picture different from the other angles, and I can see I now have an angle side angle and an angle side angle. So triangle ABD is congruent to triangle EBC by angle side angle postulate. For this next one, we're told that angle 1 is congruent to angle 2 by given. So then I can go ahead and mark my picture. Angle 1 is congruent to angle 2. I'm also told that angle 3 is congruent to angle 4 by given. So I will mark that as well. Which this tells you that if 1 and 2 are congruent, then you know that, well, that doesn't really tell you anything. If 3 and 4 are congruent, you can see that AM and RG are parallel because those would have been the alternate interior angles. So it's not necessarily important right now, but you can see that. Now, we can also see right here, though, that these two triangles share this side RM. If they share that side, then we know it's congruent to itself. So RM is congruent to RM by the reflexive property of congruence. Which now we can see angle, angle, side is congruent to angle, angle, side. So triangle RMA is congruent to triangle MRG by angle, angle, side postulate. Now, remember, if we had known these two angles were congruent and we knew that GM was congruent to RA, that would have made side, side angle. That doesn't work, so RM wouldn't have helped us because side, side angle doesn't prove triangles congruent. A way to remember that is if it spells a bad word backwards, then it can't possibly prove triangles congruent. This one, however, was angle, angle, side, so it does work. Now you wouldn't go angle, side, angle because that's taking the longer way around. You always want to go the shortest distance.